Okay, everybody, in this video we are going to learn about mineral classification. So we're going to continue our discussion on minerals. Sorry. All right, there you go. So for this course, I would like to make the mineral classifications to be very simple. Okay, I think what you need to know is that there are two main types of minerals, okay, out there. The first one is called the silicates mineral, okay, and the second one is non-silicates. I mean, if you think about it, it has the word silica in it. So silicates really consists of silicon and oxygen. Okay, and why I have to highlight silicates in this course, the reason for that is because silicates are very, very commonly found within the Earth's surface. Okay, it is a common rock forming minerals and most commonly found within the crust and mantle of the Earth. So there's a good chance if you go out there, out in the field, or just by the street and then you find a piece of rock, there's a really good chance that that piece of rock, is a silicate rock. Okay, but of course there are also other types of minerals such as native metals, sulfides, and carbonates, and I think we're just gonna call them all non-silicates. Okay. So here's a picture of quartz, and again, quartz is an example of silicate mineral because it has a silicon and oxygen in it. Now we can also subdivide silicates into two main subdivisions of minerals. The first one here is called the non-ferromagnesian silicates. Okay. Non-ferromagnesian silicates typically has, of course, it is rich in silica, and it has low density, and it has, light color. Okay, so for example, here is quartz. It has silicon and oxygen. Okay, this is plagioclase feldspar. It also has silicon and oxygen among other types of elements as well. The second subdivision of silicates would be called ferromagnesian. Okay, so this is the second one, which is called ferromagnesian silicates. And ferromagnesian silicates typically has, well, it also has silicon and oxygen. Okay, so don't forget about that. But it also has some additional elements within the mineral. So for example, it has iron and magnesium as well. So ferromagnesian silicates are rich in iron and magnesium. Now because of those metal elements, additional metal elements within the mineral, so it actually makes it a bit denser than non-ferromagnesian, okay? And it also make the color a bit darker than non-ferromagnesian silicates. And the example for ferromagnesian silicates would be olivine and pyroxene. And as you can see here, it has silicon and oxygen, but it also has iron and magnesium. Okay, here again, pyroxene has silicon and oxygen, and it also has additional metal elements such as magnesium, iron, or here in this case calcium as well. Just to remind you that I think I've talked about the concept before already, that if you have a bunch of minerals, so for example, these are all silicates minerals, okay, silicate minerals, and if you have a bunch of rock forming minerals, then if they combine, they would create a rock, okay, a piece of rock. Okay, so if you see here, these black minerals right here would represent biotite, which is in this case this guy right there. Okay, that's biotite. And maybe these colorless minerals that we see right here, that could represent the quartz of the rocks. And this type of rock is called granite. Okay, and this one is not a mineral, it is actually a piece of rock. Okay, of granite. And what is granite? Well, if you don't remember what granite is, go ahead and review the lecture on Earth system, because I talk about that over there. All right, again, these are the two main subdivisions of non-ferromagnesian silicates, and I think I would like to talk about the first mineral of non-ferromagnesian, which is called quartz. Okay, I've already talked about this many times already. And again, we have silicon and oxygen. That's the chemical formula for quartz, and it is usually clear, white, gray, or rosy or smoky color. So in terms of color, quartz can be literally has a very wide range of color, and it has a six-sided prisms. Okay, and it is not reactive chemically. So if you have a nice piece of quartz, it would look something like this. So it has some prismatic pattern on it. Okay, so look at those beautiful quartz. Now, of course, this is an environmental geology course, so I have to kind of mention something, the effect of quartz to human. Okay, the quartz can be very, very tiny, and if you are dealing with tiny particles of quartz, you do not want them to enter your lungs. Okay, because these particles can get stuck within our body, and it can cause inflammation and some other diseases. Okay, because the minerals of quartz, if it's so tiny, it is actually very sharp as well. So you don't want these things to be within your respiratory system. Okay. Now, the disease that is associated with the presence of quartz within the lung is called silicosis. Okay, this is occupational lung disease, and typically this disease is contracted by mining workers, okay, or people who actually blast the sand, all right, in quarries and metallurgical construction. But and another good example for this would be something that happened in West Virginia in early 1900s, for example. So there's a health risk from quartz. So what happened in West Virginia is that these are workers, mining workers, who enter their mine sites here without any protective equipment. Okay, so without any mask, and they probably at the time they did not know the risk associated with this job. Okay, so because they were mining something that has a lot of silica associated with the rocks, and then they have the dust that is full of silica, and then they breathe in those dust. It actually caused over 100 deaths, okay, in 1927 among these workers from silicosis. Okay, so that is the health risk associated with quartz. Now, another example for non-ferromagnesian would be feldspar. Feldspar is also a common example of non-ferromagnesian. As you can see here, these are the two main types of feldspar. We have potassium feldspar, or we usually just call it K feldspar. But we also have something that we call as plagioclase feldspar. Okay, but both of them, again, if you notice, it has silicon and oxygen. Again, we have silicon and oxygen in addition to some other types of elements. Okay, but notice that there's no iron associated with it, right? So the color, in terms of the color, it is white, milky white. That's one of the most common color for plagioclase feldspar. But for potassium feldspar, it actually looks pinkish. Okay, the color of potassium feldspar is commonly pink. And it has four-sided prisms, and it has some cleavage right here. These cleavage are just, a plane that the minerals break, okay, along, and then again, it is also one of the most common crustal minerals. Now, now there's excuse me. Now, something that is important to mention when we discuss about feldspar is that feldspar plays such an important role in producing clay minerals. Okay, clay minerals such as clay minerals can be rich in potassium, sodium, or calcium. Okay, and clay minerals they actually have a layered atomic structure that can hold water. Okay, so some of these elements can actually hold water. Okay, so for example, this picture right here shows how water got involved or got held by the clay mineral. So this is before it reacts with water. Um, and this picture at the bottom here, it is, maybe I'm, all right, there, you can see it. Anyway, this is the picture when the clay mineral expands because the presence of water within these layers of minerals. Okay. Now, why is it so important to mention? Because again, if you have abundance of minerals within a certain region and it easily reacts with water, it can expand, and then once it's dry, it contracts again, and then once it reacts with rainwater, it expands again, and this process happens repeatedly. Then it would actually cause some damages to existing structures. For example, if you have houses that are built within clay, then you would imagine that this expansion and contraction of clay within the foundation of that house would actually damage the house. Okay, so for example, you can see here these are cracks right there that could be associated with the expansion and the contraction of clay. Okay, so the shrink and the swell of clay can actually damage a property. Okay, and not only that, this is an example of a road right here, and this road is underlain by clay layers. Okay, so these clay layers will expand, especially it will become very weak during a rainy season, of course, because clay would react with water. Okay, so those are non-ferromagnesian, and in the next few slides we're going to talk about ferromagnesian silicates. And again, ferromagnesian silicates has ferro in it, and magnesium, meaning that it has a bunch of iron and magnesium within the minerals. Okay, and again, these are the two minerals that I already mentioned before. Okay, some weathering products of ferromagnesian minerals are something that we may need to pay attention to. Okay, olivine, pyroxene, and another one called amphibole here. These are ferromagnesian minerals, and they are not stable in atmospheric conditions. Okay, within the air or within the water. Okay, so they can hydrolyze. They can undergoes hydrolysis, okay, to form other types of minerals such as serpentine minerals, for example. Serpentine minerals, maybe it's okay, but chrysotile, this is also another product of weathered ferromagnesian minerals. Now, this one is something that I have to mention here. Chrysotile looks something like this. So these are chrysotile right here. This is a picture of chrysotile, and as you can see here, it has some elongate fibrous serpentine mineral. Okay, and these are minerals that actually make asbestos. Okay, I'm pretty sure you've heard about asbestos before. Asbestos is actually widely used in the United States, okay, because it has a heat resistant and it's quite flexible, okay, so it's a very good material to actually, to be integrated to some, common materials in households, okay. So again, this is chrysotile. That's the chemical formula for chrysotile right there. It is what we call as a white asbestos. Okay, and of course you don't want to breathe in asbestos because it can produce chronic exposure, chronic diseases, and this one is called asbestosis. Okay, it's a progressive lung disease that results in difficulty in breathing. It's kind of similar to silicosis as well. Okay, and asbestos has been basically in the center of attention in the past, several decades already, because asbestos are, typically used in common households. Okay, but I have to say that breathing high levels of asbestos fibers for long periods of time can lead to this type of disease, lung cancer, and mesothelioma. Okay, and symptoms of these diseases usually don't appear until 20 to 30 years after a person breathes in this asbestos. Okay, and a great increase of lung cancer would be associated with smokers as well. Okay, again, I already mentioned this, that asbestos used to be in many households, and if you don't believe me, these are all advertisements that are associated with the use of asbestos. Okay, so they are used in stoves, okay, in hair dryer, right, and asbestos is also used in pipe covers, and they are also still used here to patch the roof. Here, not really sure what this means. Let this magic mineral asbestos protect the buildings on your farm. Okay, let them protect your buildings on your farm, but you gotta be careful with that because you don't want to breathe in those things. Okay, so those are some silicates mineral and some hazards that are associated with these minerals. And let's go ahead and talk about non-silicates now. So this is an example of non-silicate mineral. For example, we have native elements, meaning that this mineral has just one metal element within the mineral. Okay, so for example, we have gold, silver, copper, platinum. All right, these are all non-silicate minerals, and these are all native elements. Okay, and as most of these native elements, minerals, they are considered as precious metals. Okay, because they're of course quite rare, and they are widely used in jewelry. Okay, so for example, we have gold right here, platinum right here. These are all examples of native element minerals. This is also another example of non-silicate minerals, which is called sulfides. Okay, sulfides means that we have some sulfur in it, and this sulfur is bound with some metal elements. Okay, so metal plus sulfur, then we would call the mineral as sulfides. Okay, it is a common metallic ore, meaning that this is the stuff that people are looking for when they're trying to mine some minerals, some mineral resources. Okay, so for example, we have minerals called galena. Okay, this guy here has lead and sulfur. Okay, we also have sphalerite right here. This mineral has zinc and sulfur. We also have calcite right here. Calcite has copper, plus sulfur. Okay, so these are the stuff that people are looking for. Copper, lead, zinc, these are all mineral resources that we use in our electronics, right? So these are the raw materials of your electronic devices that you're probably using right now. But anyway, just to show you, this is what we call as the Bingham Canyon mine near Salt Lake City in Utah. Okay, and this particular mine site is called the Kennecott Copper Mine. They are looking for copper here. Okay, copper. They're looking for copper, and just want to let you know that this is actually the largest man-made ditch on Earth. Okay, which is located in Utah. Some hazardous aspect. Some hazards that are associated with these minerals include, these sulfide minerals that can actually react with water, with rainwater or fresh water to produce harmful sulfuric acid that we see here in an abandoned mine in West Virginia or in a river in Colorado. This river, I have talked about that in previous videos already. The next minerals that I would like to talk about is called carbonates. Carbonates, as you can see from its name, it has carbon and oxygen. Okay. So as you can see here, these are examples of carbonate. We have carbon and oxygen for calcite. We have carbon and oxygen for dolomite. Okay, so these are examples of carbonate minerals. And carbonate is dissolved in acid, including acid rain over time. So it easily reacts with fresh water or meteoric water. So it actually can dissolve the rocks and the minerals. And then this is the reason why, you know, in some regions, especially regions that have a bunch of carbonate minerals, they will produce what we call as karst terrain. Okay, in this case is a sinkhole. Okay, so we got a sinkhole right here. Now this happens because of the dissolution of carbonate minerals that may underlie this region. Okay, because these carbonate minerals that they have right there basically reacted with water, and it becomes weak and produce these holes on the ground. Okay, and every time you go to a cave that looks something like this, it is also because of the dissolution of carbonate bedrock within that region. And as you can see here, we have some nice examples of sinkholes right here in this picture as well as in that picture. The next one is just want to let you know about other types of minerals that could be toxic. Okay, this is called cinnabar. Okay, cinnabar looks something like this. It's very easy to recognize cinnabar because it looks like red meat, right? The color kind of reminds me of the red meat, raw meat. But anyway, cinnabar actually is also a sulfite, but it actually has mercury in it. Okay, in fact, cinnabar is used as a principal ore of mercury. Okay, so we use when on some devices to measure temperature, they still use mercury to in thermometer in some thermometer they still use mercury to actually measure temperature. So this is the source of that mercury. Okay, so and cinnabar must be treated as toxic substances because of the presence of mercury in it. But in some regions, they actually are used as red pigment in paints and inks, as you can see right here. So these red pigments are coming from cinnabar. Okay, and they can produce toxic compounds, and the misuse of cinnabar can lead to mercury poisoning. Okay, so but I have to say that even though it looks very scary and it sounds very scary, don't worry about cinnabar, because the mercury, if you found a piece of cinnabar, for example, if don't worry about it, because the mercury within cinnabar is actually helped by the sulfur element within the mineral. Okay, now the problem is that when it becomes weathered, and the bond between the mercury and sulfur becomes so weak, this mercury can actually lose and become separated from the sulfur, and that's when mercury poisoning can happen. Okay, another toxic minerals would be the radioactivity of those minerals. So many minerals are radioactive, but some other minerals are much more radioactive than others. For example, uraninite or pitchblende right here, this is an example of a mineral that has high radioactivity. Okay, so you don't want to be close to this mineral. Okay. Now, talking about radioactive minerals, this is also something that actually happens not that far from us in at Rutgers. Okay, a long time ago, there was something that we call as the Radium Girls case here, and this case happened in the city of Orange, which is very close to the city of Newark, right there. All right, in the northern part of New Jersey. So what happened with Radium Girls is that, well, this is the background story of radium girls. Radium is a uranium ore, okay, and it has 1,000,000 times more radioactive than uranium. And in 1917 and to 1926, these type of mineral, okay, the radium right here, was used for luminous paint for military watches and instruments, okay, because this thing will glow in the dark, so it helps the soldiers to actually maybe just look at the time, all right, in the middle of the in the dark, basically, okay, because these things will glow in the dark, right? Now the problem happens, in the factory that actually made all these watches and instruments, okay. The factory girls were encouraged to point the brushes with their lips, so they use basically they wet the tip of the brushes with their lips, just like that, and then they paint it on the watches, okay. And sometimes they also, for fun, they painted their nails, teeth, and faces without realizing the risk that is associated with these radioactive minerals, okay. So women were not told to about the effects of radiums, and unfortunately, this is the real picture of the United States Radium Corporation factory in Orange, New Jersey, in 1917 or around that time. And unfortunately, many of them became sick, and some of them unfortunately passed away, okay, because of again because of the hazards that are associated with this radium, okay. So the right of individual workers to sue for damages from corporations due to labor abuse established as a result of Radium Girls case, okay, in early 1900s. Now, okay, this could be a bit disturbing for some of you, but I have to talk about this just to let you know about the hazards, the real hazards that are associated with this mineral. Okay, this picture right here on the left here is the photo of an exhumed body of a radium girl in darkness, and the body is still glowing from the radium in the bones, okay. So this radium actually got submerged or just got absorbed by the bones, and the bones become glowing. This picture was taken in the darkness, so it still glows in the dark, okay. This middle picture right here is a picture of one of the factory worker before working in a radium factory, and this is what happened to her after the exposure to radium, and it will produce something that we call as radium jaw. Okay, so they used to call it radium jaw, that developed into a gross deformity of the face of some of these girls. Okay, so it is a very unfortunate case, and it's actually one of the something that is quite famous in the case of radioactive minerals, and there are books about radium girls, and there are also I think there's a movie made based on the true story of radium girls. So if you want to read the book about them, and if you want to just watch the movie about them, you can do so, but just I think you can just Google it. All right, so I think that's it for this discussion on minerals, and we're going to continue talking about rocks in the next videos, and I'll see you over there. All right, bye bye.